Okay, so here is our last topic for interdependence. So if I jump back a slide, you can see we were on the sea anemones and clownfish as part of our symbiosis topic. So now I'm going to go into the last topic on interdependence, which are nutrient cycles. So earlier I talked about the biodomes that they tried to build that did not work. And it was because the nutrients were not cycling. And so this is often when I play some of the video that talks about why the biodomes fail. So I'll try to find it and see if I can, but right now just focusing on this. Okay, so nutrients must cycle. In other words, they can't get stuck in one place or another, and they need to keep moving from place to place and stay in balance for ecosystems and the biosphere to be healthy. So this is one type of illustration of the carbon cycle. So I had you do a different carbon cycle drawing, which we'll look at here in a little bit. So the size of the circles represents where most of the carbon is actually stored. So we see that a lot of it is actually stored in the ocean. And then we see arrows going up and down, but if you look, you'll see there's one place where the arrows are not going down. So I'm going to make that a question on the worksheet because I want you guys to figure out that certain things in this image, they're going up, but then the earth and nature are not reabsorbing them, and because of that, there's a connect that this is a global warming related topic, and we'll get into that. But for this picture, I'm not going to point it out. I want to see that you guys can figure it out. But we do see that plants, when they grow and decay, when they grow, they take in carbon dioxide, and when they decay, they release it. We also see that the ocean has some going in and some going out, and that's basically a form of diffusion, which we learned in Unit 2. So if you look at the rest of the picture, you should see an area where arrows are going up, but they are not coming back down, which indicates why we have a buildup of carbon dioxide, at least one of the reasons why carbon dioxide is building up in the atmosphere, which creates what's called the greenhouse effect, and then the greenhouse effect causes global warming. The side effects of global warming include certain things like increases in storms. So what happens is the more heat in the ocean, then you get more evaporation in the ocean. And so as the oceans are evaporating at a faster rate, they are creating large storms. and then when they start spinning, that's when they become hurricanes. And so this is actually the wall of a hurricane. These are buildings and stuff down here, and this is the hurricane, like the border of the hurricane as it shows up. So because there's more heat energy in the ocean from global warming, we're also having an increase in evaporation, leading to more enormous storms showing up more frequently. And this is why probably around when you were born in like 2005, Hurricane Katrina hit New Orleans harder than any hurricane on record, and they were not ready. And we've had more hurricanes and stuff that they're calling like superstorms. There was something called Superstorm Sandy, which hit New York City and the East Coast, where these things happen more often, and in the South. I think the difference is hurricanes are spinning, and I think the superstorms just come straight in. They don't spin. And we're also seeing increases in major storms and floods in the middle of the United States, not just on coastlines. And here we see some people that have been kind of slammed by a big flood due to a storm, trying to rescue animals, which, you know, takes a lot of courage. And then over here we see a polar bear that has been trapped on a block of ice, and there's a ship going by that took a picture. And so one unfortunate aspect of global warming, which I'm sure you've heard, is that ice caps are melting. Polar bears have evolved to go out onto the ice blocks and ice sheets and hunt, and they've evolved that in their brains there's a certain, instinct where they know when to come back because the ice is going to melt. But because the ice is melting sooner, they're getting trapped, and some of them are dying as they get trapped out there. And some kids have asked, like, why don't these people rescue this polar bear? But taking a polar bear onto a ship, I don't know who took this picture, so it could be some tourists or something, is very difficult to try to rescue a bear in this situation. So This is, these are some of the reasons why it's really important to be thinking about and creating solutions as far for this challenging concept of global warming, which we'll get into some more here now. So nutrients are chemicals that organisms need to survive, so that's why they're important. So this picture is directly related to something I studied in college at UC Santa Barbara, right by the Santa Barbara Zoo. So you guys know by now that I worked at the Santa Barbara Zoo, and before I worked there, for one of my classes, we had to go down to this pond that's right next to the zoo. You can actually find it if you go drive around the zoo a little bit in the area. It's like really close. And what it was there was all this algae on the top of the pond, and it looks good. Like, wow, there's a lot of life. There's all this thriving algae. But what happens is they're doing all the photosynthesis now. They're blocking the sun, and all the photosynthesis is happening at the top. So there's not enough solar energy reaching the plants on the bottom, and those plants provide oxygen into the water. So if the photosynthesis is happening up here, the oxygen leaves and it doesn't go into the water. So it's basically suffocating the organisms that are inside the water. And so on the surface it looks like, wow, there's a lot of life and whatever, but it's actually suffocating the life underneath. And one of the reasons why this is happening is different pollution, which can provide, coming from the land, and it can provide nutrients for that algae. Even though it's a form of pollution, and some of it was coming from like detergents and things like that that were coming out of people's homes and their pipes from laundry machines, and those detergents had nutrients that the algae liked, and this was something I had to study in college, and it's technically called eutrophication with an EU, eutrophication, if you want to look it up. Okay, so nutrients are cycled from one organism to another. So something could eat something that's alive, or it could eat something that's dead, or it could even consume its waste. And so here we see some fungus that's like breaking down this like dead plant material. And then these are actually two sort of mushroom type things coming out of this insect. And the insect ate the fungus probably on accident, and the fungus grew out of it and is decomposing it. It's actually decomposing and getting nutrients from this insect that it came out of. Nutrients can also cycle between living and non-living. This is wrong. This is worded weird. It should say sort of more like between living and non-living factors in the biosphere. I'm surprised this is wrong. Anyway, so here we have a non-living object made by humans pumping out non-living nutrients or pollution into the non-living air. And so we have a living organism, humans, creating technology that is non-living, that is cycling pollution in this case, which could be seen as a nutrient to some organisms. And then now it's going into the non-living biosphere, like the air and stuff like that. Okay, so nutrient cycles can also be called the biogeochemical cycles. So let's break that down. So bio meaning it's cycling in life, geo meaning it's cycling like with the earth, and then chemical means the nutrients. So we have nutrients cycling between living things as well as the earth. All right, so you don't have to actually know a lot about a couple of these cycles. So this picture represents the oxygen cycle, and the only thing you have to know about this, which is pretty basic, is that oxygen is cycled through photosynthesis and respiration, which we've already learned earlier in the year. So here it says plants take in oxygen and give out carbon dioxide at night. So that's kind of weird. Plants kind of use respiration, which is what the cows are using and what we use to survive when the sun is gone. So they are really efficient. In some ways, plants are superior to animals because they can make their own energy, or when the sun's down, they can do what we do, which is respiration with the carbs that they make. They take in carbon dioxide and give oxygen during photosynthesis in the daytime, and here we have animals breathe in oxygen and breathe out carbon dioxide. All right, you also don't have to know a lot about the water cycle, but here we can see there's different ways for it to go up into the atmosphere, like evaporation. And transpiration is when water leaves plants. And in the rainforest, sometimes you can actually, I have a video where they say, this one scientist said, it's almost like it's raining up, which is pretty amazing to imagine. where the water is coming up from the plants into the sky, almost like rain in reverse. And then when the cloud forms, it's called condensation. When it comes back down, we get different forms of precipitation, and then they can run off, which means, like, moving down the mountains, and that's how a lot of these shapes are carved into the mountains. Then it can seep into the ground, and this is why we have wells that go into the ground to tap into the groundwater. And then here we have roots and stuff are taking it back up, and we can see it goes back into the ocean maybe, or something like that, or into the lake. So water is cycled through living and non-living factors in the biosphere, and that's what you have to know. And this, the water cycle is really important. That's also directly related to global warming and climate change type topics, and so I'm going to tie that into our other cycles. So you guys were supposed to do a carbon cycle drawing and answer some questions about the carbon cycle, which I'll be grading soon.